Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting distance learning edition of high school geometry. Let's go ahead and jump in here. Starting a new unit today, areas and parallelograms. There are areas of parallelograms and triangles, and you covered a little bit of this in middle school, so this shouldn't be too much of a surprise on how this works. We're just going to go through it and keep this down as simple as possible. So first off, the base of a parallelogram is any side of the parallelogram, okay? Any side can be it. We typically use the one that's drawn on the bottom side, but you don't have to be. And then the height is the perpendicular distance between the two bases. So notice that this piece here is the height, not the slanted distance. We're going at the right angle. So, excuse me, I got a slight case of hiccups. So the area formula for a parallelogram is just the length of the base times the height. Now, I want you to think about what's going on here, okay? Let's say that I have this parallelogram right here on the left. And right at the height, I'm going to slice it. That's going to give me both a triangle and this kind of trapezoid over here on the right. Then I'm going to take this triangle right here and move him over and slide him over to the right hand side. Then that creates a rectangle. Now, you're used to your rectangle being just length times width. Well, length, width, base, height, just renaming it. Therefore, our parallelogram area formula is just length of the base times the height. So, pretty simple formula, and let's go ahead and see what we can do with that. So, it asks me to find my area, so I'm going to do, and perimeter. Actually, let's do perimeter first on this one. I know that on parallelograms, that opposite sides are congruent, so this is also 20 inches. So my perimeter is just going to be 20 plus 32 plus 20 plus 32, or 20 plus 32 times 2. So my perimeter is 104 inches. Now, for my area, that's going to be base times height. Well, my base is either of these two bottom sides. I'm going to use 32 as the base. But for height, I've got to know this distance here. The problem is, how do I find that? Well, I can see that I've got a right triangle there, and that means that if I can solve for this side of the right triangle, then I can find the height. So let's go over here and work on the side and do that. I just realized it looks like BB. I'm going to erase that and make that actually look like base times height. Okay, now back over to that triangle, that right triangle. A squared plus b squared equals c squared. The hypotenuse of 20 is going to be the c value. The a value is going to be 12, and b value, I'm going to put h there because it's height. So that gives me 12 squared is 144 plus h squared equals 400. Now let's go ahead and subtract that. And again, my mental math skills are not always with me. 256. And let's take our square root of 256. And that tells me my height is 16. So I'm going to take that and plug them both into the formula over here on the left in pink. Area equals the base, we already said was 32, times the height, we calculated as 16. So 32 times 16 is 512, and make sure you put your units on this. This is inches squared or square inches. Remember, perimeter is always just regular units, inches, and area is units squared, in this case, inches squared. All right, number 2, find the perimeter and area. Once again, let's go ahead and find our perimeter first, and I believe I was doing perimeters in green. Let's be consistent with that. So it's just 21 plus 17, and then the other side is going to be plus 21 plus 17 as well. Opposite sides are equal. So 21 plus 17, multiply that by 2, perimeter equals 76 centimeters. Now, area is base times height. Ooh, nearest tenth if necessary. That's going to be important. We've got to make sure we're always keeping track of what units they ask us to round to. Looks like we're doing the exact same idea here. We're going to have to do a squared plus b squared equals c squared. The reason is I've got this right triangle here on the right. So c is going to be the hypotenuse of 17. A is going to be my 8. And then my height here is going to be the b value. So 17 squared is 289. 6 squared is 64. And now 289 minus 64 is 224. Now 224, square root of 224 is 14.96, which is going to round up to 15.0. So now let's go ahead and plug this in. Base is 21, which was this value here, times 15. 21 times 15 is 315 centimeters squared. So most difficult thing so far is just doing Pythagorean theorem in order to find the height. All right, let's find the perimeter and area of this parallelogram. Now this one's a tiny bit different. So I can look at this and see that my base is going to be 23. Now this line on the outside is drawn out there. It's still at a right angle to the base. So this 24, even though it's drawn on the outside, I mean, I could put it right here. That's still going to be 24 feet. The height here is 24. So to find the area, I'm just doing base times height, which is 20. Let's actually write that right. 23 times 24. 23 times 24 is 552 feet squared. Now perimeter, we're going to have to do Pythagorean theorem, because for the perimeter, I need to know the lengths of the sides. So I need to know this side here. So I can do my Pythagorean theorem again. And now my A and B values are going to be there. C is the hypotenuse. So we've got 24 squared plus 7 squared equals C squared. And since they're on the same side, I'm just going to type them in at the same time. 24 squared plus 7 squared. Might help if I put the plus sign there. So 625 equals C squared. Square root of 625, 25. So this side is 25, this side is 25, the top side is 23, so my perimeter is just 23 plus 25 plus 23 plus 25. So that's 23 plus 25 times 2. So perimeter is 96 feet. Oh, by the way, if you're wondering why I'm actually doing this slightly differently, what I'm actually typing in is 2 times 23 plus 25. I mean, look at what I've actually got drawn on here. I've got 23 plus 25, 23 plus 25. So I'm just multiplying 23 plus 25 times 2. That's why I've done that on all of those. All right, example 4. Find the perimeter and area of this parallelogram. Now, this one, we're going to have to take advantage of either trigonometry or special right triangles. Either one will do it for you. I'm going to choose special right triangles because that's usually easier. So it looks like I've got a right triangle here that has a 45-degree angle on it. Now I know that on a 45, 45, 90 triangle, we'd said that that was S and S because it's an isosceles triangle, and the hypotenuse is S times the square root of 2. Now, what that means in particular for me is that if the bottom side of this triangle is 9, then the other leg is also going to be 9. So my height of this parallelogram is 9 yards. The base is the entire distance, which is the same as the top side, which is 17 yards. So to find my area, base times height, so that's just 9 times 17. 9 times 17 is 153 yards squared. Now for the perimeter. I already know the top and bottom sides are equal to 17. Now I need to know what the left and right sides are. Well, I know over here on my right triangle map that if the legs are S, the hypotenuse is S times the square root of 2, which means that my hypotenuse here is just 9 times the square root of 2. So both sides are 9 root 2. So to find my perimeter, I just do 9 root 2 plus 17 plus 9 root 2 plus 17. 9 square root 2. Now when you're doing this, you've got to make sure you press the over arrow, the right arrow, to make sure that you're no longer underneath the square root sign. Plus 17 times 2. Nearest tenth means I'm going to do 59.5 because 4-5 rounds up, and that is yards. Now I want to go ahead and point out what that would look like if you did it wrong. So 9 square root of 2 if I forget to press the right arrow and I just do plus 17. You'll notice the difference in the 2. The top one there, the 17 is not underneath the square root, and the second one on bottom it is. And you'll also notice it gives us the wrong answer. It's off by a full 10 yards. So make sure you're pressing that right arrow. Don't take the square root of 17. Okay, moving on to triangles. So remember, the base of the triangle is any side. Remember, we went over this quite in detail first semester when we went over triangles. It is the base of the triangle is not the thing it's sitting on. It's any one that we want to use it as. In this particular one, I'm using the triangle or the side on the left as the base. The height, also known as the altitude, is the length that goes from, or the line segment that goes from that base segment to the vertex at a right angle. So it could be anywhere. If I drew the triangle like this and I use this as the base, the height would go right here. Now the important one to remember is on our obtuse triangles, if I use this as the base, the vertex is the height is actually going to come right here. So it's an external height. So you got to be careful with that on the obtuse ones. Now the good news is that the area of a triangle is just the base times the height divided by 2, or 1/2 base times height. So it's literally find the base, find the height, multiply them, divide by 2. Very easy formula to use here. So we're starting off with one of those obtuse triangles. So I see that I have my right angle here in the bottom left, which means I'm going to use 16 as the height. But if 16 is the height, I've got to use the perpendicular side as the base. And so here, this 22 is the base, not the 8. The 8 is just this distance between the outside of this vertex and where the altitude is drawn. So area is base times height, or just do 1/2 times 22 times 16. 0.5 times 22 times 16. 176 feet squared. Now, this one also asked me to find the perimeter. Now, for the perimeter, I already know a 34 and a 22, but I don't know the length of this slanted side. Got to use Pythagorean theorem on that to find it. A squared plus b squared equals c squared. This is going to be c. 16 squared plus 8 squared equals c squared. 16 squared plus 8 squared is 320. Take the square root, and we get 17.9 feet. So then my perimeter is just 34 plus 22 plus 17.9. 34 plus 22 plus 17.9 is 73.9 feet. Okay, moving on to example 6. In this case, I'm giving you the area and asking you to find x, which is the height. So here's my base. X is the height. Now in this case, we're going to start with the formula. Area equals 1/2 base times height. Now plug in what you know. We know that the area is 357. So 357 is equal to 1/2 times the base we said was 34. So that's 34. And now the height is going to be x. So I'm going to put an x there. Now let's multiply that out. 34 times 1/2. That tells me 357 is equal to 17x. Now we're going to divide by 17. Oops. 357 divided by 17. X equals 21 inches. Okay. Last problem. The height of a triangle is 7 more than its base. Now I'm going to draw this. Technically, you don't have to draw this for it to work out, but I like to draw things. Okay, the height of the triangle is 7 more than its base. So I know that my base down here is just going to be b, and the height right here is, well, it's 7 more than the base. If the base is b, then it's going to be the base plus 7. Okay. Now the area of the triangle is 60 square units. So area equals 60, I'm sorry, not units, inches squared. Looks like we're going to have to do some solving here. And I'm going to start with my formula. Area equals 1/2 base times height. And again, I'm going to plug in what I know. Area is 60 equals 1/2. The base we have labeled as just b. The height we know is b plus 7. So we're going to have to solve this equation. And this does not look fun, but we'll get through it. Just one small step at a time and you'll be okay. So 60 is going to go along for the ride. Now, this 1/2 b, I'm going to have to distribute to the b and to the 7. So that gives me 1/2 times b. Actually, you know what? I'm going to back up a second. I'm going to do this an easier way. I want to get rid of things. For example, I don't like seeing that 1/2 out there. The way I get rid of a 1/2 is by multiplying both sides by 2. What that's going to do for me, 2 times 60 is 120. And now this 2 times this 1/2 are going to go away. That leaves me with just b times b plus 7. Now we're going to distribute this b. 120 equals b squared plus 7b. Now we're in a predicament because we've got a b squared equation, and it wouldn't surprise me if you have forgotten how to do one of these. You covered these quadratic equations with an x squared in it quite a bit when you were in algebra, but we haven't seen it too much this year. So if you've forgotten how, don't worry. Here's the biggest thing you need to keep in mind when you're solving a quadratic. If you've got both a b squared and a b, or x squared and x, if that's the type of problem you're doing, then you have to get everything on one side, set it equal to 0. The easiest way to do that on this problem is to subtract 120 from both sides, which leaves me with a 0 on the left and b squared plus 7b minus 120. So, also keep in mind that you do not subtract the 120 from the 7 because the 7 has a b attached to it and the 120 does not. Now, you were taught several different ways of doing that back when you were in Algebra 1, and well, there's lots of different ones. I want to say my favorite, but probably the most direct one is to realize that factoring is like unfoiling or undistributing. We're going to end up getting a b and a b, and then some value here. Now, that's going to be numbers that multiply to give me 120, the c value, the 120 in the end, but add or subtract to give me the 7, the middle term 7. So I need numbers that multiply to give me 120. Let's try 1 and 100, not 200, 1 and 120, or 2 and 60, or 3 and 40, 4 and 30, 5, let's see, 120 divided by 5. Not every number will work here, it just happens that the first few do. 6 and 20. I don't believe 7. Nope, 7 doesn't work. It's got a decimal, so that doesn't work. 8 does. And I'm going to stop there because I was looking for a set of numbers that add or subtract to give me 7, the middle term. And 8 and 5 can add to give me, or can subtract to give me 7. Now, I said originally that it was a negative 120, which means one of them is positive, one of them is negative, and whenever I'm done, I want it to be positive because that 7 is positive. Well, if I had a positive 15 and a negative 8, they would add to give me positive 7 and multiply to give me negative 120. So those are the two numbers I'm adding in, negative 8 and plus 15. All right, now I'm going to then split that apart into two different equations, b minus 8 equals 0 and b plus 15 equals 0. You're allowed to do that only when two things are multiplied together to get a product of 0. Now we're going to solve b equals 8 and b equals negative 15. Now, one quick thing I've got to do, I've got to double check and make sure these answers make sense. Well, whenever I look back up at the original problem, here, this length is b, and I want to take particular attention to this b equals negative 15. In geometry, we don't have negative lengths, so I am going to go ahead and cross that one out because we can't have negative lengths, which means b equals 8 is my answer, but it also wants the height, and the height we said was b plus 7, which is 8 plus 7, so the height is 15. I know that one was a long one. If it gave you problems, go back, rewatch it through. It's not that difficult, but it does use a thing that or a technique we haven't used for a while since Algebra 1. So that's all I got for you guys today. Hope that wasn't too long for you. I hope you have fun doing your assignment and your quiz. And as always, guys, stay patriotic.